multi-dimensional OLAP. Now we have understood what is OLAP. If we talk about OLAP, that we call multi-dimensional OLAP, it is a classical OLAP which facilitates the data analysis by using a multi-dimensional data cube. A proper data cube has to be used. Now, on this data cube, we can input our data in multiple dimensions. Now, this data, it is pre-computed, it is re-summarized and stored in the MOLAP, which is multidimensional online processing. This is a major difference between ROLAP and MOLAP. ROLAP stands for Relational Online Analytical Processing, in which the relations, the tables are made. But in MOLAP, we save our data in the form of data cube, which can be used for the analysis of data. Now, using a MOLAP, a user, he can make use of multidimensional view data with different facts. Multidimensional data analysis, it is also possible if the relational database is used, but that would require querying data from multiple tables. Relational database, relational OLAP, it can also be used for the analysis of data, but since our tables, our relation, they can store the data in 2D only, so for querying a data, if a particular data is queried, we need to take the data from multiple tables together. And that is another big task in itself. So, that is why we make more use of MOLAP. MOLAP, it has all possible combination of data already stored in the multidimensional array. So, MOLAP, it can access this data directly. So, MOLAP, we can say it is faster as compared to our ROLAP. Why is this MOLAP faster? Because the computations, they are already done and stored into the cube. Whenever any calculation like this is required, while preparing the data in the multidimensional array, that calculation is already being done. So, we can very easily retrieve that data. So, that makes our MOLAP faster. While in relational OLAP, what we have seen, if we need to make a query, first of all, we need to take that data from multiple tables. And if calculations are required for that particular query, from different tables, we need to access the data and make the calculation. So, that will make our process slower. So, that is why multidimensional OLAP, they are more in demand, they are more in the usage. Because of being fast, because of easily storing the data, because of easy analysis of the data. Then, if we talk about the MOLAP architecture, so we basically have three components here: database server, our MOLAP server, and the front end tool. The very first is the database server. Database server is the place where the entire data is stored. Then, this MOLAP server, it acts as mediator between the front-end tool and the database server. Front-end tool is a main tool that is going to be used by the end user for taking any data, for retrieving any data. So, this front-end tool, which is being used by the end user, if it requires certain data from the database, it has to connect to the MOLAP server first. And via the MOLAP server, it can access the data from the database server. So, considering the given MOLAP architecture, we can say the user, it requests the reports through the interface initially. That is the very first step. First step is the user who is sitting at the front end. He would request the report through the interface. Now, the second step will be the application logic layer of the MDDB, the database, multiple layer database. It will retrieve the data stored from the database. Now, the third step would be the application logic layer. It will forward the result to the client and to the user. So, that is going to be the third step. So, first of all, the user will request the data through the interface. Second step will be the application logic layer. It will retrieve the stored data from the database. Now the third step will be again the application logic layer. It will forward that result to the particular client or to the user who will ask that data for. So OLAP architecture, it mainly reads the pre-compiled data. OLAP architecture, it has limited capability to dynamically create the aggregations or to calculate the results that have not been pre-calculated and stored. Let us understand it with the help of an example. An accounting head, he can run a report showing the corporate profit loss account for the entire organization or for the specific subsidiary. So this OLAP architecture, it would retrieve the pre-compiled profit and loss figures and display the results to the user. So that is how this OLAP architecture, it uses the data, it analyzes the data and delivers the results to the user. So OLAP architecture, it mainly reads the pre-compiled data. So the three parts of OLAP architecture that we've seen here are: first is a database server where the entire data is stored. Mediator is our OLAP server which will help us access the data from the database. And the first and foremost thing is a front end tool where from the user will access the data. So that will be the first thing, the front end tool where our end user would be sitting and he will raise a query for any particular data from the database. So that is how the architecture of OLAP is. Now, thinking in more than two dimensions. OLAP, Online Analytical Processing. It is a software for performing multi-dimensional analysis at high speed on large volume of data from the data warehouse, from the data marts or from some other unified centralized data store. OLAP, this will be used to understand the data from different dimensions. Like in a particular data warehouse where we have all the data stored. So we need to analyze that data on the basis of different dimensions. So OLAP, it is all about thinking about data in more than two dimensions. Now, most business data that we see, they have multiple dimensions, multiple categories into which the data can be broken down for the representation, for the tracking or for the analysis. Example, if we talk about the sales figure. Now sales figure, it might have several dimensions that are related to the location. If you want to analyze the sales, so we can analyze the sales according to the location, the region of that particular data, to which country that data belongs to which state that data belongs to which particular provenance or to which particular store. So there are different dimensions related to the location also that we can analyze. We want to analyze a sales figure. Similarly, for the time, if we want to analyze a time, that at what point of time the sales are more. So we can analyze the data for the whole year or maybe for any particular month or some particular week or even for a single day. So time has different ways of analysis. And in a very similar way, if we talk about the product. So if we talk about the clothing. So the clothing is a product. The clothes can be for the men, for the women, for the children. And then the clothes can be of any particular brand that we want to analyze, any particular type that we want to analyze and more. So if we even talk about the sales figure, we can analyze the data from number of dimensions. So for analyzing this data from different dimensions, we make use of our online analytical processing software. Like in a data warehouse, now the data sets, they are stored in tables, each of which it can organize the data into just two of these dimensions at a time. If you want to analyze a table, what can we store? We can store the data only in two dimensions. One is a row wise, we can store the data. One is a column wise, we can store the data. So at a time in a data warehouse, we can analyze the data on the basis of only two dimensions. But OLAP, It extracts the data from multiple relational data sets and organizes it into a multi-dimensional format, which enables very fast processing, and it also provides insightful analysis of the data. So basically, OLAP, it helps us to think in more than 2 dimensions. So that is why we make more usage of OLAP to analyze our data properly. Now, what are the possibilities? In a multidimensional model, the records, they are, like we have seen, they are organized into various dimensions. And each dimension, it will include multiple levels of abstractions which are described by the concept hierarchies. Like we have seen, if you want to describe the time dimension, so this can be described in the hierarchy of day, week, month and year. So this data, it is described in a particular hierarchy in our database. So it provides multiple level of abstraction. Now any organization, it will support the user with the flexibility to view the data from various perspectives that they want to see. A number of OLAP data cube operations, they exist to demonstrate these different views, allowing the interactive queries and search for record at hand at the same time. So OLAP, it supports a user-friendly environment for the interactive data analysis. Our OLAP, it is a technology behind many business intelligence applications. It is a powerful technology for data discovery, including capabilities like limitless reporting. In a limitless way, we can view our reports. It can provide us complex analytical calculations if we need to calculate our data. If we need to calculate the sales figure of any particular location, we need to do complex analytical calculation for that. So OLAP provides us that. And predictive what if scenario too. Like we can forecast our budget, we can plan our products, and what if analysis scenario, it provides that what if we increase the supply of this demand, what will happen. So this kind of predictive what if scenario is also provided by our OLAP structure. So these are the various possibilities in the way we can use our OLAP structure, our OLAP software. So that is why nowadays OLAP, it is a technology behind various business intelligence applications. What is the reason behind? The reason behind is that it provides us the limitless way to view our data. It provides us with the complex analytical calculation. And not only this, it provides us with the predictive what if scenario. So these are the reasons, these are the possibilities because of which we are making more and more usage of our data, because we require to analyze our data from different level of abstraction. We do not want all the data to be displayed at a particular point of time. If we want to analyze a particular brand of clothing, if there's an e-commerce website, like you have Amazon, like you have Myntra, Ajio, any particular e-commerce website that you see. Now, on those websites, there are a number of brands of clothes. So, if we want to analyze any particular brand, that what is the sale of this particular brand, so that we keep more products of that, if the sale is more. And if the sale is of that particular brand, it is not there, why should we collaborate with that particular brand into our e-commerce website? So for that analysis, we require our online analytical processing, because there is so much of data, there are so many brands, we cannot just manually keep on looking for every brand and analyze the data. We cannot even store the data into the relational structure, that is in the table format, because it will provide us with the data in only 2 dimensions. So for all these purposes, to overcome all these things, we require our online analytical processing.